Good afternoon. Let's start our lecture today. Last time we were trying to solve this wave equation, right? So x is in x is in 0 to 2 pi. I think x in 0 to 2 pi. T is in 0 to infinity, and you have all of the initial condition and boundary condition as 0. So you x at 0 is 0, ut x at 0 is also 0. All right. So this is the wave equation that we were trying to solve. You have the second derivative in x is equal to the second derivative in t, and x is taken from 0 to 2 pi, t is taken from 0 to infinity. You have an initial condition. I think I missed something, right? So you x at 2 pi. You x at 2 pi. T is also 0, right? So you have a boundary condition at 0. At x is equal to 0. You have a boundary condition at x is equal to 2 pi. You also have initial condition at t is 0 and ut at 0, right? By the way, I put the final exam online. So you have until December 16 to submit the final project to me. So that will be at 5 p.m. Late projects will not be accepted, and you have to type them, right? And you send it by email to me, right? So let us continue with this problem. So the eigenvalue problem that we define the basis. Right, so the eigenvalue problem that we have is, so phi second is equal to lambda phi when x is in 0 to 2 pi. And then you take this initial condition, this boundary condition, so you have phi at 0 is 0, and phi at 2, phi x, phi prime at 2 pi is also 0. Right? So the first step is always to solve the eigenvalue problem. All right? So in this case, you have to solve this eigenvalue problem. Phi second is lambda phi. So these boundary conditions comes from the fact that u at 0 is 0, and this boundary condition comes from the fact that ux at 2 pi is 0. I claim that the solution of this equation is 0, so let us check. All right? So how can I solve this eigenvalue problem? Yes?
We can set up the characteristic equation.
Yes, inside by the white paper, please. So the characteristic equation will be r square is lambda. Case number 1, lambda is positive. So what happens when lambda is positive? Yes?
You have two roots. It's a nice square root of that.
Yes. So you have two roots, right? One is square root of lambda, and R2 is minus square root of lambda. In this case, the solution will be C1 e to square root of lambda x plus C2 e to the minus square root of lambda x. All right? Now what is the next step? Yes?
Plug in the boundary condition.
Yes, can you say it back paper, please? So the next step will be to use the boundary condition, right? So phi 0 is 0, which means that C1 e to the 0 plus C2 e to the 0 will be 0. So C2 will be minus C1. So phi x will be C1 e square root of lambda x minus C1 e square root of minus lambda x. All right? So after you plug in the first boundary condition, you find that C2 is minus C1. You replace C2 with minus C1 into this solution. You found this form. What is the next step? Yes?
Plug in the second boundary condition.
Yes, can you say at the back of this? So now you're going to use the second boundary condition. To use the second boundary condition, you're going to have to take the derivative. So you have C1 square root of lambda is square root of lambda x plus C1 square root of lambda is minus square root of lambda x. Alright? Because the second boundary condition involves a derivative, so what you do is you take the derivative of this guy. The derivative of this guy is C1 square root of lambda is square root of lambda x plus C1 square root of lambda is minus square root of lambda x. So now you have phi prime at 2 pi is 0, which means that C1 square root of lambda is square root of lambda times 2 pi. Square root of lambda is square root of lambda times 2 pi with the minus is 0. Alright? So when you plug 2 pi into this expression, you have C1 square root of lambda is square root of lambda 2 pi plus square root of lambda is to the power minus square root of lambda times 2 pi is 0. So what can we say about C1? Yes? Yes, can you stand back further, please? So in this case, C1 is 0. So again, you obtain nothing from this case. Right? Case number 2, lambda is 0. So what happened when lambda is 0? Yes?
Then your phi double prime is 0, so then you take the integral, and so you get phi is ax plus b.
Yes, can you stand back further, please? So in this case, phi second is 0, which means that phi x is ax plus b. Right? Now what is the next step? Yes?
What are the boundary conditions?
Yes, can you stand back further, please? So now you use this the first boundary condition, right? Phi 0 is 0, which means that a times 0 plus b is 0. So b is 0. So phi x is now ax. Right, so what is the next step? Yes?
Applying the other boundary condition, you find out that a equals 0.
Yes, can you stand back circle, please? So now you're going to find the derivative of this guy. This is a. So you replace the second boundary condition. You get a is equal to 0, right? So again, in this case, you don't have anything from which is non-trivial, right? So because in both cases, 1 and 2, you found only phi x is 0. Right. So this is not a. This is only a trivial solution. This is not an eigenfunction. Case number 3. Lambda is negative. What happened when lambda is negative? Yes.
There would be two roots, which would be plus or minus I times the square root of the absolute value of b.
Yes. Can you stand at the back please? So in this case, the two root will be plus or minus I square root of lambda. Right. So phi x should be a cosinus of square root of lambda x plus b sinus of square root of lambda. Alright? Now what is the next step? Yes? Yes, can you stand back for a please? So now you plug the first boundary condition. This gives you phi 0 is 0, which means that a cosinus of 0 plus b sinus of 0 is 0. So a is 0. Now I found that a is 0, so phi x in this case will be b sinus of square root lambda x. Alright? So what is the next step? Yes?
Take the derivative and plug in the second boundary.
Yes, can you stand at the back paper, please? So now we have phi prime of x is b square root lambda cosinus of square root lambda x. So, so you have phi prime at 2 pi is 0, which means that cosinus of square root of lambda is 2 pi is 0. right? So what is the value of, what can you say about lambda? Yes?
Because square root lambda times 2 pi has to equal n pi plus pi over 2. So then we can solve for lambda.
Yes, can you say that, please? So which means that lambda times 2 pi will be n pi plus pi over 2. Right, so square root of lambda will be n over 2. So that's 1 over 4. Lambda will be minus n over 2 plus 1 over 4 squared. So in this case, Px will be sinus of square root of this guy. There's an absolute value. Right? So this is going to be sinus of n 1 over x. Right? So because cosine of this guy is 0, which means that this guy has to be n pi plus pi over 2. Which means that lambda, square root of lambda has to be n over 2 plus 1/4. And lambda n has to be minus of this guy square, and phi n will be sinus of this guy. So you have the basis. And you have the eigenvalues. Right, so what is the next step? Yes?
Expand the basis.
Yes, can you say at the back paper, please? Right, so the next step is to write so the next step is to write u in terms of this basis, right? So u is going to be the sum when n is going from 1 to infinity of a and t times sinus of n over 2 plus 1 over 4 x. All right? So now you're going to expand the solution on this basis. So what happened when I take the second derivative of this guy? Yes?
We'll have an double prime with the sign function instead.
Yes. At the back paper, please. So this is going to be, sum n is going from 1 to infinity a and t double prime sinus of n pi to x. All right? So now I want to take the second derivative of utx. Yes?
It'd be the sum of, from 1 to infinity of a7 of t times the second sine prime of
Yes.
all of that.
Can you say at the back of the paper, please? So this is going to be the sum when n is going from 1 to infinity of an sinus of n over 2 plus 1 over 4 x second derivative, right? So what is this second derivative? Yes?
It's just lambda and phi n in this case, but that's phi and double prime.
Yes. So this guy, you're going to replace it by minus n over 2, 1 over 4 square, sinus of n over 2 plus 1 over 4x, right? So you know that this second derivative will be lambda n phi n. So which means that dxx utx will be the sum when n is going from 1 to infinity of minus an t n over 2 plus 1 4 square sinus of n over 2 plus 1 over 4 x. All right? Questions? Now, because this dt of u is equal to the xx of u, what can you say about the coefficient? Right, so from the equation, you know that utt is equal to uxx, which means that this utt has to be equal to this, yes?
So that negative a n t times lambda is equal to a n double prime t.
Yes, can you stand at the back of the paper, please? So you're going to have this guy is equal to this guy. Because they are the coefficient of the same function. Right? Because this function is the same with this function, which means that this coefficient has to be the same with this coefficient. Right? So we have an second t is equal to an t minus of n over 2 plus 1 over 4 squared. So how can I solve this second order differential equation? Anyone else? So this is second order differential equation, right? How can you solve it? Yes?
Well, it's in the form of the eigenvalue problem. So like an double prime equals lambda and an. So we can take case 3 and then an of t is going to equal to c1 cosine squared absolute value of lambda t plus c2 sine
And
absolute.
can you sign the quick of this? So now this is a second order differential equation with constant coefficient, right? Which means that you have to look at the characteristic equation, right? Characteristic equation. So in this case, you have x squared is equal to minus of n over 2 plus 1 over 4 squared. Because this is a second order differential equation. So what you do is you use the characteristic equation. In this case, you have two roots, which is I plus or minus I n over 2 plus 1 over 4. So ANT has to be C1n cosinus of n over 2 plus 1 over 4 t plus C2n sinus of n over 2 plus 1 over 4 t. Right? So this is the standard second order differential equation with constant coefficient. For this kind of equation, again, you use the method of characteristic equation. The characteristic equation will be x squared minus n over 2 plus 1 over 4 squared. This characteristic equation has two roots, plus or minus I n over 2 plus 1 over 4, which means that ANT has to be C1 cosinus plus C2 sinus. Questions? Right, so now I have the A1n formula. I'm gonna plug it back to the form of U over there. Right? So UTX will be, so when n is going from 1 to infinity, of C1n cosinus of n over 2 plus 1 over 4 t plus C2n sinus of n over 2 plus 1 over 4 t times sinus of n over 2 plus 1 over 4 x. Right? Now you plug this an into the formula that we have here. And this is the new form of the an, of the UTX, after you compute the explicit form of an. Right? So we need to find C1n and C2n. How do we find them? Yes?
Well, first you need to plug in the initial condition.
Yes, can you sign the back of this? So, so now we have to plug in the first initial condition, right? So you have what? You have U. U at 0 is 0. So this is the first initial condition, right? So I think so this is xt. So this should be xt. So the first initial condition is 0, right? But what happens when you replace t to be 0 in this formula? Yes?
C2n sine n just 0 over 0. So you have C1n sine n of this equals 1 for
Yes, can you say the back of this? So when you plug t to be 0 here, what you get is the sum when n is going from 1 to infinity of c1n cosinus of 0 plus c2n sinus of 0 times sinus of n over 2 plus 1 over 4x. Alright? From this formula, when you plug t to be 0, you have 0 here and 0 here. So which means that this gives you c1n sinus of n over 2 plus 1 over 4x. So how do you find c1n? Yes?
You can take the inner product now.
Yes, can you say the back paper please? Because all of these guys are orthogonal, right? So c1n, so this is 0. So you compute c1n by taking the inner product of 0 sinus of n over 2 plus 1 over 4x dividing by sinus of n over 2 plus 1 over 4x sinus of n over 2 plus 1 over 4x. Right? Yes?
Won't this just be 0 though?
Yes, this is 0. Right. So this is 0 because this is integral from 0 to 2 pi of 0 times sinus of n over 2 plus 1 over 4x dx dividing by something. And, right? Dividing by this inner product. Sinus of n over 2 plus 1 over 4x sinus of n over 2 plus 1 over 4x. Right? So this inner product is nothing but the integral. You multiply 0 with this function, you take the integral. And of course, this integral is 0 because you multiply that by 0. This is 0. Questions? It's good. Alright, so you know that C1n is 0. So in this formula, you don't care about C1n anymore. Right? Now we only need to find C2n. How do you find C2n? Yes?
Use the same process with the other initial condition.
Yes.
U prime of x 0 is 0.
Yes. Inside the back paper, please. Right, so after you found that C1 is 0, so after you find C1 is 0, you need to find C2, but C2 is also, C2 can be computed by using the second boundary condition. You have the derivative of u at t at a point 0 is 0. So I have to take the derivative with this guy, right? So I have to take ut of xt. So what is ut of xt? Yes?
Wouldn't it just be, n over 2 plus 1/4 cosine?
Yes, can you add back my place? So you're gonna take the derivative of this guy, right? So this is going to be a sum when n is going from 1 to infinity of C2n n over 4 plus 1 over 2. But you have to have a minus, no, there's no minus, please. So this is n over 2 plus 1 over 4 t. sinus of n over 2 plus 1 over 4 x, right? So now, what is the value of this sum, I guess?
You put n over 4 plus 1 over 2 should be n over 2 plus 1 over 4.
Ah, yes. Can you sign it back? Right. So what happened when I replace t to be 0 into this series? Yes?
Since the top gonna be, or the inner product, it would be 0.
No, no. I just want to see if I replace t to be 0 into this series, what happened? Yes?
You have put sign of n over 2 plus 1 over 4x time of c2 and all of this cosine will be 0.
This one.
Cosine 0.
Can you sign it by a purpose? So this is going to be the sum when n is going from 1 to infinity of c to n over 2 plus 1 over 4 cosinus of 0 sinus of n over 2 plus 1 over 4 x, alright? So cosinus of 0 is 1. So this gives you the sum when n is going from 1 to infinity of c to n over 2 plus 1 over 4 sinus of n over 2 plus 1 over 4x. Right? Now, how can I compute this c to n? Yes?
Again, you take the inner product.
Yes, can you sign my paper, please? So now you plug this 0 here and you take the inner product, right? So you have c to n times n over 2 plus 1 over 4. You have to have this factor because this is the whole coefficient. Right? So you have 0 sinus of n over 2 plus 1 over 4 x, and then you have sine squared n over 2 plus 1 over 4 x of sinus of n over 2 plus 1 over 4 x. Alright? So you have c to n times this guy is going to be the inner product of 0 times sinus over sinus. So what is the value of this? Yes?
Wouldn't it also be 0?
Yes, can you sign the back paper, please? So because this is nothing but an integral, this is also 0, which means that c to n is also 0. Alright? So c to n is 0. So what is the solution now? Yes?
You have x equals 0.
Yes, can you sign back paper, please? So c to n is 0, which means that here you replace that as 0. So you have the sum of everything of a series of 0, so utx is going to be 0. So this equation has only one solution, which is 0. Questions? That's good. All right. Any questions on this process? So if there's no questions, let's go to another equation. So you have UTT is 4 times UXX plus sinus of t. UX 0t will be 0. U2 and t. 2, 0 is 0, and ux as 0 is 1 minus x squared over 4. Ut of x is 0 is 0. Alright, so this is so for x in 0 to 2, t from 0 to infinity. Right? So this is the equation that we have to solve. So this equation is different from the previous wave equation. What is the difference? Yes?
We're multiplying UXX by 4 and adding the sign term.
Yes, there's a 4. And you add back and the paper piece. But this 4 is not a serious problem, right? Because we know how to do it. What is the next difference? Which is more serious? Yes?
The fact that sine t is being added.
Yes. Can you say the back paper, please? So in the previous equation, you don't have anything here, right? Yes?
Is the very first term UTT?
Yes, this is UTT.
Thank you.
This is still the wave equation. So in the previous, all of the previous exercises, you don't have this sinus, and this was very easy. Now, I put a force here that is trying to control my wave equation. And this sinus will make things much more complicated, all right? But the process will be the same. All right, so this is harder because non-homogeneous. Force. So this wave equation is harder because the force is non-homogeneous, which means that you do not only have UTT is equal to UXX, or UTT is UXX times something, you have really something, so you have to add something on the right hand side. All right, so the process will be the same. Now, you're gonna have to find the basis. This is the eigenvalue problem. So the eigenvalue problem will be phi second is equal to lambda phi, and this is x is from 0 to 2. And what are the two boundary conditions for this thing? Yes?
Phi prime is 0, 0, and phi of 2 equals 0?
Yes, can you send back paper, please? So in this case, you also have phi prime at 0, is 0, and phi at 2 is 0. Right? So the eigenvalue problem is always easy. How do you solve it? Yes? Yes, can you send back paper, please? So you have the characteristic equation. So this is R squared is equal to lambda. So case number 1, lambda is positive. So what happens when lambda is positive? Yes? Yes. Yes, and back paper, please. So you have 2 roots plus or minus square root of lambda. So the solution will be C1 is square root of lambda x plus C2 e to the power minus square root of lambda x. Alright? Alright, so what is the next step? Yes?
Plugging the first boundary condition.
Yes, can send back paper, please. So now you have to plug the first boundary condition, which means that you have to take the derivatives. So you have C1 square root of lambda is square root of lambda x minus square root of lambda C2 is minus square root of lambda x. And so you have phi prime at 0 is 0, which means that C1 square root of lambda e to the 0 minus square root of lambda C2 e to the 0 is 0, which means that C1 is equal to C2. So I replace C2 by C1 here. So I have C1 is square root of lambda x plus C1 is minus square root of lambda x. All right? So the characteristic equation is R squared is lambda. You consider 3 cases again. Lambda is positive, so you have 2 roots. The solution has to be C1 is square root of lambda x plus C2 e to the power minus square root of lambda x. Now, you plug the first boundary condition and you found that C1 is equal to C2. What is the next step? Yes?
Plugging the second boundary.
Yes, can you sign back the paper, please? So now you're going to use the second boundary condition. P2 is 0. So when C2 is 0, P2 is 0, you have C1 e square root of lambda times 2 plus C1 is power minus square root of lambda times 2 is 0. So what is the conclusion? Yes?
C1 is 0.
Yes, can you sign back paper please? So in this case C1 is 0. So in this case you don't have anything. Case number 2. Lambda is 0. So what happens when lambda is 0? Yes?
Phi double prime is 0, so phi prime is ax plus b.
Yes, can you sign back paper please? So in this case phi double prime is 0, which means that phi x is ax plus b. Alright? What is the next step? Yes?
Can I take the derivative?
Yes, can you sign back paper please? So you're gonna take the derivative of this guy, this gives me a, and you use the first boundary condition. You have phi prime is 0, which means that a is 0, right? So phi x will be b. What is the next step? Yes?
You plug in the second variable.
Yes, can you sign back paper please? So now you know that phi of 2 is 0, which means that b is 0. So in this case you don't have anything, right? Questions? Right, so case number 3. When lambda, case number 3, lambda is negative. So what happens when lambda is negative? Yes?
We have to.
Yes, can say back paper please. So in this case you also have two roots, plus or minus I square root absolute value of lambda. So so phi x will be a cosinus of square root of lambda x plus b sinus of square root of lambda x. Alright? What is the next step? Yes?
Are we using A and B or C1 and C2? Or I guess it doesn't matter, but.
It doesn't matter.
Yeah, okay.
Yeah, so you can use it. Yeah, you can call it C1,
C1.
C2. It's just a name. Right? So what is the next step? Yes? Yes, can you stand back paper please? So now you take the derivative of this guy. So the derivative of this guy is C1 square root of lambda cos as minus square root minus sinus of square root of lambda x plus C2 square root of lambda cosinus of square root of lambda x right? What is the next step? Yes?
Find the boundary.
Yes, can you say it back paper please? So now you apply 0 here. So you have C1 square root of lambda sinus of 0 plus C2 square root of lambda cosinus of 0 is 0, which means that C2 square root of lambda is 0. Which means that C2 is 0. So the x has to be C1 sinus of square root of lambda x. Right, so what is the next step? Yes?
You plug in the second boundary condition.
Yes, can you stand it back please? So, so you plug the second boundary condition, right? So you have phi 2 is 0, which means that sinus of 2 square root of lambda is 0. Right? Yes?
Didn't we say C2 equals 0, so shouldn't be actually C1 cosine?
Yes. So this is cosine. Alright? Right, so because here C2 is 0, so the level is the C1 cosine. So now you have cosinus of 2 square root of lambda is 0. What is the value of lambda? Yes?
It's negative n pi over 2 plus pi over 4 squared.
Yes, can you sign it back paper please? So for now, now you have 2 square root of lambda is n pi plus pi over 2. So square root of lambda is plus pi over 4. So lambda will be minus n pi over 2 plus pi over 4 squared. And then phi n x will be cosinus of n pi plus pi over 2x. All right. So we have this eigenvalue and this eigenfunction. Right. So. Right, so questions? Right, so it's correct, right? No?
Shouldn't p of x be n, cosine of n pi over 2 plus pi over 4?
And pi over, yes, thank you, and sin pi over 2. Yes. Right, so this is what we have. This is the basis, all right? All right, so now the next step, you're gonna do the same thing, right? So you're gonna expand u, tx, like the sum when n is equal to 1 to infinity of ant phi nx. All right. So I have to take the utt. What is utt? Yes.
It's an double prime t p of x.
Yes. Can you sign the back paper, please? N of x. Right. Right. So now, what is for uxx? Yes.
It'd be 4 times the summation of a sub n of t times phi prime prime of x.
Yes. Can you sign back paper, please? So this is going to be 4 times ant phi n second x. So what is phi n second? Yes.
Lambda n phi n.
Yes, can you sign the back paper, please? So this is lambda n phi n, right? So this is the sum when n is going from 1 to infinity ant 4 times lambda n phi n x. All right. I put the 4 inside. Right, but this guy is not this guy, right? So there is something in between. Yes?
Isn't it also we have to expand upon the sine of t because it's 4uxx plus sine of t because like to make them equivalent, right?
Yes, yes, yes. Right.
So you have to expand.
Yes. So the next step is to expand sinus of t. So we need to expand, right? So we need to expand. Ut sinus of t in terms of sum when n is going from 1 to infinity of pnt pn of x. Right. Right. So can you say it back to this? So now you have to expand. So now you need to expand sinus of t on this basis, right? So in other words, sinus of t needs to be the sum when n is going from 1 to infinity of pnt cosinus of n pi over 2 plus pi over 4 x. All right. So how can I compute Bn? Yes?
Say the inequality.
Yes, can you stand back, please, of this? So again, whenever you compute a coefficient, you need to take the inner product, and this is the only thing that you have to do. Sinus of cosinus of n pi over 2 plus pi over 4 x. So this is cosinus of n pi over 4 pi over 4x, and cosinus of n pi over 2 plus pi over 4 x. So the idea is, again, you need to expand this sinus of t on the basis, right? So you have to write sinus of t as someone bn, when n is going from 1 to infinity of bn t times pi pn. To compute this bn, again, you use the fact that all of these are orthogonal. So in order to compute the coefficient, what you do is you take the inner product of sinus of t with cosinus in x, and then dividing by the cosinus, right? Conscious? So now let us compute the first guy. Sinus of t, cosinus of n pi over 2 plus pi over 4 x. So what is this in the product? What is the definition of this inner product? Yes?
Integral from 0 to 2 sine.
Yes.
70 times cosine.
Yes, can you say back to about this? So you have interval from 0 to 2 of sine cosinus of n pi over 2 plus pi over 4 x dx. Right? So how can I compute this interval? Yes?
You can treat sine of t as a constant.
Yes.
And then the antiderivative cosine is sine divided by what's inside.
Yes, can say about this. So I can pull sine t outside, so I have the interval from 0 to 2 of cosinus of n pi over 2 plus pi over 4 x dx. Right? Because this is an interval in x, so the sinus of t doesn't play any role. I pull sinus of t outside. So how can I compute this interval? Yes?
It would be the sine of n pi over 2 plus pi over 4x divided by n pi over 2 plus pi over 4
Yes,
from
yes.
0 to 2.
Can you sign back by this? So this is sinus of t times sinus of n pi over 2. Right, so dividing by n pi over 2. This is from 0 to 2. So what is the value of this guy? Yes?
It would just be 0 in this case because sine of, when you plug in the 2, you
No.
end up, what do we do?
No, it's not 0. Yes?
Negative 1 to the n.
Yes, you can send back paper, please. So the 0 here will be 0, but the 2 is not 0, right? So we have sinus of t, sinus of n pi plus pi over 2, dividing by n pi over 2 plus pi over 4, right? So this guy is minus 1 to the n. So we have sinus of t dividing by n pi over 2 plus pi over 4 times minus 1 to the n. Alright? Because sinus of n pi plus pi over 2 is minus 1 to the n. Alright. Now, how can, so for the second interval, I have to compute, right? So cosinus of n pi over 2 plus pi over 4 x n pi over 2. So let me write this half here. So here I have sinus of t minus 1 of 1 over n over times 1 over n pi over 2 plus pi over 4, right? So I replace the result that I computed here to this place. Now, I have to compute the second guy. Right, so now I have cosinus of n pi over 2 plus pi over 4 x cosinus. I have to take this in the product. What is it? Yes?
We have the integral from 0 to 2 of 1 plus cosine of pi over 2 plus, or n pi plus pi over 2 x over.
Yes. Can you say the back paper, please? So this is integral from 0 to 2 of cosinus square of n pi over 2 plus pi over 4 x dx. Right? So this is 1/2 integral from 0 to 2 of 1 plus cosinus of n pi plus pi over 2 x dx. Right? So here I use the formula that 1 plus cosinus square is 1 plus cosinus of 2x divided by 2. Right? Explain again. So here I have to take the inner product of cosinus and cosinus, which is nothing but the integral from 0 to 2 of cosinus square of this guy dx. So the cosinus square is 1 plus cosinus of 2x divided by 2. So I apply this formula here to compute this integral. So what is the next step? Yes?
Separate the integral.
Yes, can sign back paper, please. So now you want to separate the interval. So here you have the integral from 0 to 2 of 1 dx and 1/2 integral from 0 to 2 of cosinus of n pi plus pi over 2 x dx. What is the value of the first integral? 1. Yes, can sign back paper, please. So what is the value of the second one? 0. Yes, can you sign back paper, please? So here you have 1/2 sinus of n pi plus pi over 2 x divided by n pi plus pi over 2. Evaluating at 0 and 2, so this gives you 0. So basically this is 1. Right? So because this is 1, I don't have to care about it. Alright? Questions? Alright, so this is the BN. Any questions on this computation? Right, so now you have 4xx plus Bn of t plus sinus of t. It's going to be the sum when n is going from 1 to infinity of ant times lambda n plus bnt bnx, right? And bn is computed here. All right? Questions? So, I take the sum of this guy and this guy. So, in order to take the sum of this guy and this guy, I'm going to take the sum of an times 4 lambda n plus bn. And bn is computed over there. All right? Now, you know that uxx is, utt is 4 times uxx plus sinus of t, which means that this guy and this guy, they're equal. What can you say about a coefficient? Yes?
That a and double prime of t is equal to what's in the brackets.
Yes. can you say it back paper please? So because this utt is equal to uxx plus sinus t, so what you have is an, second is ant times 4 lambda n plus bnt. And this is the equation. The bn is this guy. So the bn is minus 1 to the n sinus of t dividing by n pi over 2 plus pi over 4. Right. Questions? All right. So again, this is a second order differential equation. This is second order differential equation. This is second order differential equation with constant coefficient. But non-homogeneous. So how do you solve a second order differential equation with constant coefficient but non-homogeneous? Yes?
Find the minus solution and the particular solution.
Yes, excellent. Can you say it back paper, please? Do you remember the name of this method?
No.
Yes?
This is the superposition.
Yes?
Like when you guess, like, oh shoot, I didn't make the guess
No.
or something.
So you have to find a particular solution, which is a very good answer. But what is the name of the method? This is in 3.1.2.3. Introduction to differential equation. This is the method of undetermined coefficient. Right, so I recall you. So the method of undetermined coefficient is the following. Method of undetermined coefficient. So when you have a differential equation of the type a more u second, no, not u, v second plus b, v prime plus cv is ft. All right. So whenever you see this equation in which ft is non-homogeneous, ft is not 0. So what you do is the following: you find a particular solution. Xp, right? So this is guess. This is guessing. So this is review. So whenever you see a second order differential equation with constant coefficient, but it is non-homogeneous, what you do is you guess a particular solution. So we have x. So I say this VP. So the VP second plus B, VP prime plus CVP is equal to FT, right? And then we consider the difference. W is V minus VP, right? So what is the so this difference, W is V minus Vp, is a solution of a differential equation. What is the equation for W? So if we solve this equation and Vp solve this equation, V minus Vp solve what kind of equation? right? So if V is the solution of this guy and VP is the solution of this guy, I'm going to take the difference. What is the difference now?
And wouldn't the difference just be like the air of it?
Yes. And then what is the solution? What is the equation for this difference? There's an equation for this difference.
The f of t would be equal to like 0? Or?
Yes, excellent. Can you sign back on this? Right? So when you subtract the two equations, you get a homogeneous equation. Right? Because when you subtract the two equations, you have what? You have A V prime plus B, V prime plus CV minus A, V second minus B, V prime minus CVP is FT minus FT. And this is 0, right? So you subtract this to this, you get this minus this is FT minus FT, and this is 0. So you now combine this one and this one, you get A, V minus VP second, plus B, V minus VP prime, plus C, V minus VP. This is 0, right? So you combine this guy with this guy and this guy with this guy. All right? So if you want to solve an equation which is inhomogeneous, what you have to do is to find a particular solution that solves this equation, and you subtract the two. The difference will be AV minus V second plus B V minus VP prime plus CV minus VP is 0, right? So this gives you A W second plus B W prime plus CW is equal to 0. How can you solve this equation? The last equation, how do you find W? Yes?
Characteristic equation.
Yes. Can you sign back paper, please? So you solve this by the characteristic equation, right? So this is the method of undetermined coefficient, and we're going to use it to solve this equation, all right? So this is from the 3000 level class, differential introduction to differential equation. And I mean, on my YouTube, I'm teaching this class in the morning, so on YouTube I have videos of this explanation. So if you look into the YouTube, all of my YouTube videos, you will see it. Or you look into the book of Haberman, you will see it. Right, so now we have to find a particular solution of this equation. So we find a particular solution. So you need to find A second plus is equal to A times 4 number 3 plus minus 1 sinus t over n pi over 2 plus pi over 4. So you guess one solution, right? So particulars. So how do you guess this particular solution for this equation? What is the form of particular solution that it should be? So this is an equation of T, and in the inhomogeneous term, you have a sinus. So what is the form of the particular solution?
No, we would set it equal to 0, the right hand side of our equation, right?
No. I want to find one solution. I want to find one special solution, right? So I have to guess one solution. So what is the form of this solution that I should choose? No. I want to guess one solution. So what should I guess? Yes? Yes?
It's related to sine.
Right. Can you send a back paper, please? So I'm gonna get the solution of this type. Plus b cosine t. Right? So there are 9 cases in the book of Haberman. You remember? So to find a particular solution. But the 3 most important cases are when ft is e to the t, Vp should be a e to the t. And you have to compute a, right? When ft is cosinus, sinus, a combination of cosinus and sinus, Vp should be a cosinus of t plus b sinus of t. Ft is t to the m, right? So the first, this is in the book of Haberman. You will see that there are 9 cases, but the most the 3 most important cases are the case when ft is e to the t times some constant, right? And then here you have e1 plus e2 sinus t. So when ft is exponential, you have a constant times exponential, the particular solution should be of the form a e to the t. And you substitute this a into the equation and you find a. When ft is e1 cosinus t plus e2 sinus t, the particular solution should be a cosinus t plus b sinus t. So in this case, you see that here you have a sinus, so the particular solution should be sinus, a times cosinus plus b times cosinus. All right? And in the last case, if the force is of the type e to the m, what is the form of the particular solution?
Ax to the t.
It has to be similar to this guy. Right? So if this is exponential, this should be exponential. If this is cosinus, sinus, this should be sinus. And here, what is the form? Plus t to m minus 1. So you have to go all the way down to 0 degrees, right? So actually, Vp will be Cm t to the m plus Cm minus 1 t to m minus 1 plus C1 t plus C0, right? So this is the so-called method of undetermined coefficient in the Haberman book. So this is Introduction to Differential Equation, and this is also a 3000 level class, Introduction to Differential Equation, so you can go back there if you don't remember, right? So we guess that the particular solution will be of the type AP is A sinus t plus B cosinus t, right? Right, so and we want to find A and B. So now I have AP prime. I have to take the second derivative of this guy, so that I plug it back here. So what is the second derivative of this guy? Yes?
Negative a sine t minus b cosine.
Yes, can say. And the back paper, please. So you have minus a sinus of t minus b cosinus of t. Right. So I have to identify the coefficient a and b, right? So this is the method of undetermined coefficient. So I substitute this into the equation. You have a minus sinus t minus b cosinus t is equal to ap times 4 lambda n plus minus 1 to the n sinus of t. No. A sinus t plus b cosinus t times 4 times lambda n plus minus 1 to the n sinus t over pi over 2 plus pi over 4. Right? So I suppose that the solution has the form a sinus t plus b cosinus t. I substitute that into the equation. So the AP second will become minus a sinus of t. The AP will become this guy, and this guy is the same. I rearrange the term. So I rearrange the term. So I put all of the sinus together, right? So I have minus a times 4 lambda n sinus t minus plus minus b times 4 lambda n cosinus t is equal to minus 1 to the n sinus t over n pi over 2 plus pi over 4. All right? Questions? So again, this is a little bit, if you, so this requires a little bit of knowledge from the differential equation class, in which you guess a special solution using the method of undetermined coefficient, right? You want to solve this equation. What you do is that you look into the form of sinus of t, right? Because you see that this has a sinus of t. You guess that the solution has the form a sinus t plus b cosinus t. You take the second derivative of this guy and you plug it back to the equation. You have minus a sinus t minus b cosinus t. This guy is a sinus t plus b cosinus t times 4 lambda n. So if in the case that you don't remember this piece of knowledge, so I recommend you this way. All right. So in all of those things, what you see is sinus and cosinus on the right hand side, right? So in general, you're gonna mimic this sinus. So you have a sinus t plus b cosinus t. So if here you have cosinus t, you also have to fill sinus t here, right? And here if you have sinus t plus cosinus t, then here you also put sinus t plus cosinus t. All right. So this is the guessing. Right, so because this is the guessing, you have to compute a and b. You plug this back into the equation. You have AP second is this guy. So this is AP second, this is AP, this is 4 lambda n, this is the shocks. Now, I group all of the sinus together. I have minus a times 4 lambda n sinus t. Here I have minus b 4 lambda n. So this is the thing here. So what can I say about AB from this equation? Yes?
You compare the coefficients of sin t on the left and the right side, and you get minus a 4 lambda n is equal to minus 1 to the n of n minus 2 is minus 4, and b would be 0.
Right, can you say the back click of this? So what you can see is that, okay, this sinus of t and this sinus of t has to have the same coefficient, right? Because, which means that you have minus a times 4 lambda n is minus 1 to the n over n pi over 2 plus pi over 4, right? So here you have sinus and cosinus, here you have sinus, all right? So, and then here you have minus b 4 lambda n, but here you don't have cosinus, so which means that this guy is 0. So this guy is 0, right? So this guy is 0, meaning that b is 0. The first guy, I'm gonna have a is minus of 1 minus n over 4 lambda n pi over 2 plus pi over 4. Right, so this is minus 1 to the n plus 1 over lambda n times 2n pi plus pi. This is a, right? Which means that the solution that we have to have is AP is equal to minus 1 n plus 1 over lambda n 2n pi plus pi sinus of t. This is one solution of that equation. Yes?
And should we do 4 lambda n factor minus A.
So this one, right?
Yes. We have minus 1 minus 4 lambda.
Can you say the back paper, please? So here you have 1 plus, right? Excellent. So here you have, right, so which means that here you have 1 plus 4 lambda n pi over 2 plus pi over 4. So here you have 1 plus 4 lambda n. Here you have n over 2 and pi over 4. And so this is the particular solution, which is quite complicated. Questions? It's clear? Right. So the difference between this problem and the previous problem is the appearance of this sinus t. So if you don't have this sinus t, you use the method of characteristic. But in this case, you have this sinus t, right? So when you have this sinus t, you are solving a second order differential equation with constant coefficient, but this equation is inhomogeneous. So you go back to the classical method solving the differential equation, which is called the method of undetermined coefficient. The method of undetermined coefficient says the following. So in the case that you don't have 0 here, you cannot use the method of characteristic. This is not applicable. In that case, you have to look into the sinus and you guess the solution. Right? So if here you have sinus, you have to guess that the solution has to have the form a sinus b, a sinus t plus b cosinus t, right? So you plug it back to the equation. You have ap second is minus a sinus t minus b cosinus t. You plug this second derivative here, and you plug a sinus t plus b cosinus t here. Here you have 4 lambda n, and here you have minus 1 sinus c over n pi over 2 plus pi over 4. Right? So now you have to identify the coefficient. The sinus here, group with the sinus here, gives you minus a times 4 lambda n sinus t. The cosinus here, group with the cosinus here, gives you minus b 4 lambda n cosinus t. And on the right hand side, you still have this sinus. Alright? Now we have to identify the coefficient. So the coefficient here has to be equal to the coefficient here. So minus a times 4 lambda n is minus 1 to the n over n pi over 2 plus pi over 4. Minus b 4 lambda n has to be 0 because here you have cosinus and on the right hand side you don't have cosinus. So it has to be 0. In other words, b has to be 0. So you solve this one, you found a has to be of this form, which is quite complicated. So you plug it back and you find one solution. And so this is the AP that you have. But this is only one solution, right? So one solution is that AP, right? AP is minus 1 to the n over 1 plus 4 lambda n sinus t n pi over 2 plus pi over 4. This is only one solution. How do I find all of the other solutions? Yes? Yes, can you say the back paper, please? Right? So now you subtract the two, right? So what I said before is an minus is a times 4 lambda n plus minus 1 to the n sinus t over n pi over 2 plus pi over 4. But AP also solve this equation. N pi over 2 plus pi over 4. So now I consider W to be AN minus AN AP. So in this case, W second solve the homogeneous equation. Right? After you find one solution, you take the difference between AP and AN. This difference solves the homogeneous equation. So how can I solve this homogeneous equation? Yes, can you have back paper, please? So for this, you use the characteristic equation method. All right, so happy Thanksgiving.
Thank you very much.
Thank you.